So in this demo, we're going to focus specifically on finding packets. And that might sound like a pretty trivial thing. You're used to just doing a control F in the middle of a document or on a web page to find a certain string, and that makes sense in that context. But that's something you're also going to want to do in Wireshark, especially in cases where you have a lot of packets to deal with. And in most cases, you will have a lot of packets to deal with. I know in this course, we narrowed down the packets for specific exercises because we don't want to have too much clutter when we're trying to focus on just a very specific learning objective. But in the real world, anytime you go to capture packets, even if you're only concerned about one thing, you're going to get a lot of things. So, I mean, you can use capture filters to limit what you're getting, but a lot of the times you're still going to have to become proficient at whittling a capture down to just the things you want to see. And even then, there may be a specific string or a specific series of bytes you're looking at that you want to be able to find within that packet capture to as a place you can pivot to in your analysis. And Wireshark makes that easy. It actually makes it as easy as you might do it in a document, given that you might do a control F and just type what you want in and search for it. So it does allow for that functionality, but there's a little bit more to it. So I want to actually talk through that and also demonstrate here what that might look like in a couple of the different scenarios we're going to encounter when just trying to find specific values within a packet. So here you'll see I have a file open called http://espn.pcap. This is just a very simple file. It contains a capture from when I browsed to espn.com and just captured all the traffic associated with that. Now, there's a lot of packets here. It looks like if you look at the bottom, there are 956 packets. So that's a lot. You might not expect there to be that much when browsing to just an individual website, but ESPN pulls in content from all kinds of other domains, all kinds of different content delivery networks, and there's a whole lot of graphics and different things going on and various integrations with social media platforms and whatnot. So we actually have a lot going on here, and that's why just this simple visit produces so many packets and so much traffic. Now, in this case, we want to find some specific strings, and I can pull up the find toolbar. One way is just go to edit and find packet. And you can also, you see there, just hit Control F. So Control F will bring up this additional little toolbar right here that's going to allow us to do our finding. Now, there are a couple fields of interest here. The most important is this field right here where it says display filter right now. And this actually tells us where we want to perform our exactly how we want to perform our find, because finding in Wireshark is not as simple as just Control F and then you input what you want. You have to tell it how you want it to look and where you want it to look. In this case, it's telling us it's going to use a display filter. Now, you can actually just enter a display filter in this bar right here, this filter bar where it says apply display filter, but nonetheless, Wireshark defaults to the display filter option. Now, we're not going to talk about display filters right now. That's more of a little bit of an advanced type of filtering, and we're not concerned with filtering specifically right now. We're concerned with finding things. So we're going to click that and see the actual options we have, and we are going to look at these other three options here. Particularly, we have the ability to search based upon a hex value, so we can put a series of hexadecimal bytes and search for those. We can search for a string, which is going to be, I think, the most useful that you'll use on an everyday basis. And we can also search for a regular expression. So do some complex searching based upon a regular expression to see things that fit a pattern and not so much a specific string. So we're going to ignore display filter for now and focus on these other three things. Now I'll start with string, and I'm going to spend probably the most time here because I think string is the most useful. Now when I click on string, you'll notice a couple things happen. First of all, it turned red in this text input area because I don't have a value to search for. That'll turn green when I put something else in there. Now on the left side here, you see we have another box that is opened up for us. And this is where we input where we want to perform the search. And you'll see that the three options are the packet list, packet details, and packet bytes windows. So our three main Wireshark windows. In this case, when we want to search for a string, we have to tell it where we want it to look because a string means different things in different areas. So there's only a very limited number of strings in the packet list, and most of the time those are going to be in the info column or maybe another specific column you've added. Whereas down here in the packet details and packet bytes, you're searching through raw data and through those expanded protocol headers, and it's going to be a little bit of a different game. So I don't find myself searching through the packet list too often, but I do often find myself searching through packet details and packet bytes because that's where all the other data that is not the easiest to find is located here. So with that said, let's go through an example here, and we'll go ahead and set this to packet details. And we're going to just go ahead and search for ESPN. Of course, we know we're browsing to ESPN, so we want to see what that looks like. So if I just hit find on here, it's going to bring me to the first occurrence of that from referencing from where I was. So in this case, I was on packet 1, and it searches forward, and so it brings me to packet 2 here, and it goes in and shows me where it finds that. In this case, it expands the packet details window and shows me that the string ESPN is located in the queries section of this packet. So that's pretty neat. It brings me right to it. Now I can click find again, and it's going to take me to the next occurrence. In this case, it looks like it's in this packet 6, which is an HTTP GET request, and it looks like the host value is ESPN.com. So it found that content there. We'll click it again, and we see we have a response here. In this case, the location field comes back, and this 301, HTTP response code 301, which means move permanently, and it's redirecting the browser to go to espn.go.com. And you'll see I can click this multiple times. We have another DNS query here, more DNS, here's an HTTP request. So it's basically looking through, in this case, the packet details window and finding every occurrence of the text ESPN and taking me to that. So I can click this a bunch of times. There's going to be obviously a lot of occurrences of the phrase ESPN when I'm browsing to that website. So that's pretty cool, and it's just a very simple way to search and find some strings that match something we're looking for. So let's focus that use case in a little bit and try to do something that might be a little more practical, a workflow you might actually experience in your day-to-day. So in this case, we know we have a bunch of HTTP requests going on. So I'm going to go ahead and go to this Analyze option here, or actually I'm going to go Statistics and go down to HTTP and go down to Requests. So this is just a little option that will show us all the different requests that are being made in this capture. And as I mentioned, there are quite a lot of them to a lot of different domains. So we see ESPN.com, we see masters.com, we see log.go.com, and this list goes on for quite a while. So these are all the files being requested. Now in this case, let's say I want to dig in on one of these files further for whatever reason. I'm troubleshooting a script. There's one that's running a little slow. One looks like it might be malware. Could be a lot of reasons. In this case, we'll go down here, and this one looks interesting. Let's say we're interested in node-tag.js, which is a JavaScript file, and we just actually want to see what that file looks like. It's being transferred, and if it's not obfuscated, then probably we can see what that is and what it's doing. So I'm interested in node-tag.js. So what I'm going to do here is go ahead and close out of this window, and I'm going to go up here and search for node-tag.js, and we're going to keep that in the packet details window, and it's going to bring us right to it, right? It looks like it's in packet 761, and it's going to bring us, and we see there's a GET request here for node-tag.js, that file. In this case, I can go ahead and right-click that, tell it to follow the HTTP stream. At the top, we see, indeed, we have this GET request for node-tag.js. We see some additional HTTP header info on the request. And then we see the HTTP response, which in this case includes the short JavaScript file here. So we can actually look at that, learn a little bit about it, what it does. We're not going to go through that right now. Decrypting JavaScript's a little outside the scope of this course, but we did find the file, and that was our goal. So remember, the goal here is to find things, and that allowed us to find it really quickly. It just took a couple seconds. So you want to get used to being able to look for things, find inputs in this case. So we made an observation, and then going out and finding that and getting in terms of questions and answers, we saw something that maybe looked weird. So node-tag.js, we said, what does that script look like? And then we answered that question by finding the specific packet and opening up the HTTP stream to extract the contents of that script. So that shows us how we can search for strings pretty easily. But what if we want to search for bytes? Well, we have that option too, and it's pretty easy as well. I'll go ahead up here to where it says string and change that to hex value. So we want to search for a specific set of bytes. And you'll notice it grays out a lot of other windows. In this case, that's because there's really only one place you can search for bytes, and that's in the packet bytes window. So very specific, that's what we're going to look at. It tells us that node-tag.js is not a valid value for this, of course, because that's a string. It's not a series of bytes. So go ahead and get rid of that. Now in this case, let's say we want to search for let's just search for ESPN again, right? Let's say we didn't know what we were looking at necessarily, and we just had a weird string of bytes we wanted to find. Well, we can do that very easily. So ESPN translated from ASCII to hex bytes is going to be this right here. So it's 6573706E is ESPN in hexadecimal. And no, I did not do that conversion right off the top of my head. Now, I input that in here. It turns green, so it tells me it's a valid value, and I'll hit find. Sure enough, it finds it here in packet 867. It finds it down here at the bottom. Notice it also highlights it here in the packet details window, not just packet bytes, so it's highlighted in both places so we can see that. Let's see if there are any other instances. Well, it looks like there's one in packet 761, but wait, what just happened there? We actually went from down here, went from packet 867 back up to packet 761. So we got to the end of this and started at the beginning. And that's important to note. The reason it did that is because we're only showing a certain number of packets. So you see we're only showing maybe about a dozen or so packets here, and we're looking at a filter that says TCP stream equals 19. And that's because in the previous example, we followed a TCP stream and limited our display to just that specific stream. So when I did this find command, it's only doing that in the currently displayed packets. And that's an important thing to be aware of. When you do a find, it's only doing that search through whatever is displayed. It's not doing it through everything else. So instead of the, down here at the bottom, we have 956 packets. Instead of looking through all those, it's only looking through 10 of them, which is about 1% of the packets. So if we actually want to search for this throughout the rest of the capture, we have to go in here and clear out the filter by clicking that X. And then we have to go in here and then we can click find again, and we'll find, of course, at this point, several more instances of ESPN.com, or in this case, the hexadecimal bytes that represent that. So searching hex is just as easy as searching strings. You just have to make sure you choose the hex value option here when you're going about the process of searching for hexadecimal bytes. So let's take the knowledge we just learned about how to use the find command and apply it to a little bit more of a practical scenario. You'll see I've opened a different packet capture here. This one's called ratinfected.pcap. And this was a capture I took from a machine that I suspected might be infected with malware. Right, and this is a common use case. You'll get an IDS alert, or you'll get a user reporting something weird going on, and then you maybe suspect that some malware was installed on the system. So you perform a capture from that system and dig through the packets to see what's going on. Now in this case, we have a lot of packets, but they don't look relatively remarkable. We see they're just all identified with the TCP protocol. It looks like it's all going from port 6643 to port 4433, and there's not a lot that we can learn from the packet list window itself. Looks like we have communication between two specific hosts, but that's kind of all we can tell as we scroll through this data. Now, in this case, I got an IDS alert along with this, and it told me that there was actually a specific malware family that was at work here, and then it could be identified with a specific string. So I was able to take the name of the malware family, look into it, and find what that string was. Now, the malware family name doesn't really matter for this exercise, but I'm going to go ahead and open up the find packet window and search for that string to see if it is present. So what I'll do here is I'll go ahead and type that in. It's Anna Bilgi, which I believe is either some nonsense or it's maybe something in a foreign language, not necessarily an English word. And in this case, I'm going to search through the packet details and hit find. And you see at the bottom of the screen down there, it says no packet contained that string in its dissected display. So you might think, okay, well that string doesn't exist. However, I want to choose something else here. I'm going to go ahead and change that to packet bytes and hit find. And what do you know, there we have it. It shows up here in packet 4. If I click it again, it looks like it's going to show up a few more times in several other packets. So this illustrates that you have to be very careful about where you're searching when you're trying to find packets based upon a certain string. In this case, this string does not appear in our dissected packet view because this isn't a dissected protocol. This is actually a piece of malware that's using a custom protocol. And for the most part, if you look here, we just have this data section which shows up as a bunch of bytes. And it's only when those bytes are converted into ASCII that we see this string appear. Of course, that's not happening automatically because there's no protocol dissector for this specific protocol in Wireshark. And that's going to be a common occurrence when dealing with malware or maybe some other highly custom protocols, maybe if you have custom applications or developing your own. So you have to be really aware of that. In most every case, if I'm searching for a specific string that's found within the data portion of a packet, I'm pretty much always going to search packet details first and then search packet bytes as well. Because just because it doesn't appear in packet details doesn't necessarily mean it won't appear in packet bytes. So you want to make sure to search both of those, because again, packet details is searching the dissected packet based upon the protocol dissector. But if it's not dissected perfectly or the exact right way, it might not be present, but it could be present in the packet bytes. So that's very important to consider here. So that's going to bring us to the end of this section on finding packets. We went through a couple of different examples of finding things based upon strings and one on finding hex bytes. I think in general you're probably going to use string matching, the most common here. But remember, you can also use regular expression matching too. We have an option for that. I think there's a lot of different scenarios where you want to use regular expressions, particularly if you're not looking to match a static string, but instead you're looking to match anything that matches a pattern. So maybe a string of text followed by a number, gate1.php through gate9.php. You can use a regular expression to match those different things. Another common scenario you might run into is wanting to look for anything that contains base 64 encoded data. So in that case, you could use a regular expression that will match the base 64 character set, do a search on that, and look for base 64 encoding, which could be the sign that something malicious is going on, or maybe you're looking for an email attachment that you know to be encoded in base 64, something of that nature. So there's a lot of flexibility here. I think you'll find yourself using this feature a lot. We're certainly going to use it in some of the practical exercises we're going to continue to go through in this course, so make sure you familiarize yourself, make sure you play around with it, and make sure you understand the nuances of finding packets in Wireshark and using find carefully to search through the packet list, packet details, and packet bytes windows.